Hello, it's dumplet here. Here's an item on number theory. N is a positive integer such that n cubed minus 8n squared plus 20n minus 13 is prime. What are the possible values of n? Credits to the Art of Problem Solving community for this item. As usual, pause this video if you'd like to give this item a try. But if you're done, let us dive into the solution. Now, here we have an expression, a cubic expression to be exact, and we have this expression to be prime. So whenever you see something like this, maybe you want to see if this is actually factorable, because if it is, then we can try to assign factors the value of 1 or negative 1 depending on the scenario. So let's try to check here. So we have n cubed minus 8n squared plus 20n minus 13. Let's check if this is factorable. Now, well, if we want to factor something, we'll try to use the rational root theorem to tell us if there are any nice factors. So we have a nice constant term here of 13. So if this were to equal 0, then it should be, n should be at least one of these values. So these are the only possible rational numbers that will make this expression 0. So let's try to see 1. Now if I substitute 1, I'm going to get 1 cubed minus 8 times 1 squared plus 20 times 1 minus 13. So that's just 1 minus 8 plus 20 minus 13. And that's negative 7 plus 7. So indeed, 1 is a root to, 1 is a 0 of this expression. So I know that there will be a factor of n minus 1. So I know that this can be factored into n minus 1 times some other expression by the factor theorem. Now we can use synthetic division to help us simplify our work. So let's try to do synthetic division. We're going to take the the coefficients of the expression. So 1, negative 8, 20, and negative 13. Right? Let's bring the first digit down to be 1. 1 times 1, let's give 1. We add these two, we're going to get negative 7. Negative 7 times 1, that gives negative 7. 20 minus 7, that gives 13. And then 13 times 1, that's 13. We add them, it's going to be 0. As expected, this becomes the remainder. And these three terms will become the coefficient of the resulting, or the other factor. So we can convert this, starting from the right. This will be the constant term of 13. This will be the n term. So n raised to 1 term, and this will be the n squared term. So we can actually factor n cubed minus 8n squared plus 20n minus 13 into two factors. Well, this 1 means n minus 1 is a factor, and then this part tells us that n squared minus 7n plus 13 is a factor. So we can have this expression. Now we can verify that this expression, n squared minus 7n plus 13, it cannot be factorable. It cannot be factored further. So we can try to do our cases now. So since n is a positive integer, n is greater than or equal to 1, well, n equals 1 doesn't work, so we can rule that out already, because if n equals 1, then this becomes 0. So we can just consider the case actually that n is greater than 1. Now, why do I write this down? It's because if n is greater than 1, then this is positive. So if that's positive, this can never be negative, because I want the outcome to become a prime number. So I only have two cases, so no negative 1s here. So I'll just have n equals 1 equals 1, or n squared minus 7n plus 13 equals 1. So no negative 1s here, because both of them must be positive. So the first part is easy. It gives me n equals 2. And then the second part, it's quadratic, but it's kind of doable. We have n squared minus 7n plus 12 equals 0. So this can easily be factored into n minus 3 times n minus 4 equals 0. So we should have the two roots, n equals 3 and then 4. So from the two cases, we have 2 and then 3 and 4. So the possible values of n are 2, 3, and 4. And this is our final answer. Hopefully you guys learned something new from this video, and I'll see you in the next one. Bye bye!